Right, so here is yet another perimeter and area type problem. So the following shows two congruent or identical parallelograms overlapping with each other. So as you can see here, we have parallelogram ABCD and ADFE overlapping together to make this following shape. Given that the area of the whole figure is A, find an upper bound for the value of A. Now this might be a little bit tricky, which I will go through on later. And I need to express x, which is the perpendicular distance from D to AG, right here, in terms of A, our area of the whole figure. To solve part A, we need to relate an equation relating to the area of this whole figure A. So we can just do the trick that we have done in our previous example about counting the area of a certain overlapping figure like so. So let's just do that. So here we can take the area of the first figure, which is just a parallelogram, which will be 20 times 30. Then the area of the second parallelogram, which so happens to be congruent. However, notice that we have counted this region twice, so we need to just subtract by one of them. However, we don't really know the area of that yet, so let me just write the area of triangle ADG. Now let's just take a moment to notice here. Notice that this thing right here represents area, and in Euclidean geometry, this thing right here is always positive. So what it tells us is that we have set an upper bound for A, that A must be less than 1200. Notice that this thing right here just simplifies to 1200. So our upper bound for A right here will be just A is less than 1200. Alright, for part B it's a little bit simpler. Notice that I've just rewritten our original equation up here to look something like in terms of our area ADG. Notice that the area of ADG, according to our diagram, is equal to a half times its base 20 times its unknown height x. So we can just write that. Now expressing this in terms of x, we'll get that x is equal to 1200 minus a over 10.